and this I can do much more easily. So it's just a matter of rewriting it, being a bit clever about it. Okay, in the home stretch here, two more. These two are interesting to look at together. If you see, I've got sine of x over 1 plus cosine of x. Then I've got sine of 2x over 1 plus cosine of x. So they're similar, but the difference is obviously I've got the multiplier here. Well, I'd say that when you're looking at these, the most straightforward thing is just to be like, well, if I take the derivative, if I make my, my substitution the cosine, then when I take the derivative of that, this will go away, and that's what I want. If I made the u be up here, when I take the derivative of that, this is not going to, in a sense, go away. It's going to be still complicated. Might be possible to do it that way, but it's not as easy as saying let u be equal to cosine squared of x, and then du is equal to, u is just going to be equal to cosine, not cosine squared. U is equal to cosine, then I've got negative sine of x dx. So just be careful you know which direction you're going in. Derivative of sine is cosine, derivative of cosine is minus sine. Now this then becomes the integral that will be negative, because that negative sign, I pull that out, and I've got then 1 over 1 plus u squared du. Okay? And now this I can do by just saying, well, that's going to be the arctangent of u. And then I, again, when I complete all of these, I will substitute back in where the u was, what it was set equal to. We'll do an example of that in a minute. Now this one's a little bit different. This one is going to be, I'm going to rewrite not the denominator, but the numerator. That's still cosine squared of x dx, and this is going to be, well, this is your double angle formula where it's x plus x, and it's just going to be 2 sine x cosine x. It's worth memorizing those trig identities. Okay. Then what do I do? Well, again, if I write this a little bit like I have in this earlier one, where I say, okay, let sine, or if I just let u be cosine of x, and then du is equal to minus sine x dx, and now I just make my substitution. This then is going to be equal to minus u, and I still have the 2 there. Minus u right there, and then this then is the du, pull the minus sign, I'll pull the minus sign out, and then it's 1 plus u squared du. And now this one is a lot like the very first ones I've done, where I could say, well, let v then be equal to 1 plus u squared, and dv is equal to 2u du, and I could make a further substitution then and get this one simplified as I did the other ones. All right, but I'm going to move along because I want to try to keep this as short as possible and try just 2 concrete examples. So here's one where we're actually taking the definite integral. We're going from 0 to 1 of this rational expression here, and clearly I know if I take the derivative of e to the x, I get e to the x. If I take the derivative of x, I get 1. So it looks like I'm going to let this be my u, and then this will go away when I make my substitution. So u equals e to the x plus x, du equals e to the x plus 1, then dx, and I then will make the substitution that it becomes 0. I'm going to make a substitution for 0 in where it's e to the 0 plus 0. So e to the 0 is 1 plus 0. And then when I substitute in 1, e to the 1 plus 1 is just e plus 1. Now you can keep it all in your subbed form, in your u form, Or you could sub back if you wanted to. Some people prefer doing it that way because they wind up with something that they may feel is more complicated. But you'll see it does not make any difference. Both will be correct. So this then becomes 1 over u du. And this then is going to be, when you integrate it, it's going to be the ln of u evaluated from 1 to e plus 1. And then that's going to be the ln of e plus 1 minus the ln of 1, which is 0. So the answer is the ln of e plus 1. This one, again, we're looking for a part that I can find when I take the derivative of this. And just remember, if I consider my u to be the square root of x, when I take the derivative of that, it becomes 1 over 2 root x, and I'll get this in the denominator here. So that makes a lot of sense. So it becomes 1 over 2 root x dx. It's worth memorizing that so you can do it quickly and efficiently. It crops up a lot. So then if I plug in 1 here, I will have the square root of 1 equals 1, and the square root of 4 equals 2. So since my substitution is the square root of x, this becomes from 1 to 2 the integral of, I actually need to get rid of this 2 here because it's 1 over x. So I'm going to multiply both sides by 2. And this then becomes 2 times e to the u du, which then is equal to 2 times e to the u evaluated from 1 to 2, which is 2 times e to the 2 minus e to the 1, or e. And so that's the answer for that one. Okay? Went pretty quickly. Hopefully that made some sense. Good luck.